say 2 star. So the exercise number 1. Say this. 2 star a car engine the car battery move 3.75 times 10 to the 21 electrons. Through the starter mode. Through the starter mode. So how many coulombs of charge? How many coulombs of charge were moved? Right? So we know that we're moving 3.75 times 10 to the 21st electrons. We know the charge of the electron. So we want to know how many coulombs of charge were moving. So what we have to know here, the charge of one electron is minus 1.60 times 10 to the negative 19 coulombs. Right? This is coulombs per electron. This is the charge of one electron. So what they want to find in this case, the total charge that was moving. All right? So what we can do, we have the number of electrons. And the number of electrons was 3.75 times 10 to the 21 electrons. And we know the charge of one electron. If you want to know the total charge moved, the total charge moved will be equal to the number of electrons moved times the charge of one electron. We multiply the charge of one electron times the number of electrons moved, we will get the total charge that was moved. So total charge moved would be number of electrons, 3.75 times 10 to the 21st electrons, times charge of the electron, negative 1.60 times 10 to the negative 19 coulombs per electron. So the electrons are going to cancel out. And when you multiply this, you will get negative. So the total charge moved is negative because what we're moving were just electrons, right? And this total charge would be negative 6.0 times 10 to the second. So minus 600 coulombs. So in this exercise, if we want to find total charge moved, we multiply the number of electrons that were moved times the charge given for only one electron. And that gives us the total charge that was moved. Okay? So this is a very easier exercise, right? But it's an exercise where we work with, the charge of the electron and with this concept of, what is charge, what is the total charge, right? Now, there is a second exercise that I would like that you think about it before I just offer the solution. And in this exercise number 2, they say a piece of plastic has a net charge of positive 2.00 microcoulombs. So the net charge of that piece of plastic, like this one, for example, is positive and is 2 microcoulombs. So they say, how many more protons, more protons than electrons, how many more protons than electrons this piece of plastic has. This piece of plastic has. Right? Now, what information I will give you? I will give you that the charge of one proton is equal to the charge of the electron but positive. So if I have to find now how many more protons than electrons we have in this piece of plastic, what would you propose to do? What do you think we should do? We know the total net charge, that is 2 microcoulombs positive. And we know the charge of one proton. So if you want to know how many protons we have in total, what would you do in this case? There are more protons than electrons, and that number of protons in excess is proportional to the total charge, to the net charge of the piece of plastic. So basically, if we want to find the total number of protons in excess, we must divide the net charge by the charge of one proton. We must divide the net charge by the charge of one proton. If we divide the net charge by the charge of one proton, we get, the number of protons in excess, right? Now, what is important to know? When they say that the net charge is equal to 2 microcoulombs, micro is 10 to the negative 6. Micro, this mu means micro, is the prefix micro. And micro is 10 to the negative 6. So when they say that we have 2 microcoulombs of net charge, they say that we have positive 2.00 times 10 to the negative 6 coulombs, times 10 to the negative 6 coulombs, because each microcoulomb is 10 to the negative 6 coulombs. So we can substitute the microcoulomb by by 10 to the negative 6 coulombs. Now, what are we doing next? We can now divide to calculate the number of protons in excess. We can now divide the total charge or the net charge by the charge of a proton, by the charge of a proton. So what is this net charge? 2.00 times 10 to the negative 6 coulombs divided by the charge of one proton, 1.60 times 10 to the negative 19 coulombs per proton. The coulombs are going to cancel out. Okay? So we have to divide 2 by 1.60. When you divide 2 by 1.60, you get 1.25. 1.25. Now, look at this. The division of 2.00 times 1.60 is 1.25, but you have this 10 to the negative 6 and the 10 to the negative 19, that is in your denominator, goes to the numerator as 10 to the 19. 10 to the positive 19. And this is protons. So 10 to the negative 6 times 10 to the 19, adding the exponent, the radius subtraction, is going to be 10 to the 19 minus 6, 10 to the 13. So you get 1.25 times 10 to the 13 protons. 1.25 times 10 to the 13 protons. How many coulombs? How many coulombs of positive charges are there in four kilograms of plutonium? 4 kilograms of plutonium. Plutonium is a nuclear fuel, right? It's what we use in the nuclear power plants, right? You can use uranium and plutonium. So, given its atomic mass is 244 U, and that each plutonium atom each plutonium atom has 94 protons. Has 94 protons. So how many coulombs of positive charges are there in 4 kilograms of plutonium, given its atomic mass is 244, and that each plutonium atom has 94 protons? So what is the information that is given here? We know the mass of plutonium. And is 4 kilograms of plutonium. Now, we know the atomic mass. what is the atomic mass? The definition of atomic mass is the quantity of matter right, contained in an atom of an element. Contained in an atom of an element. This atomic mass is basically given by the mass of the neutrons and protons that you have in the nucleus of the atom, right? This atomic mass is basically given by the mass of the neutrons and protons that you have in the nucleus of the atom. Now, when they say that the atomic mass is 244 U, is because they are using a unit that is called atomic mass unit. U is an atomic mass unit. And 1 U, 1 atomic mass unit, is equal to 1.660 539 040 times 10 to the negative 39 grams. Each atomic mass unit is equals to that. So, if the atomic mass unit of 1 atom of plutonium is 244 U, let's convert that mass of the atom of plutonium from atomic mass units to grams. So we can convert the atomic mass of plutonium from atomic mass units to grams. So we multiply this 244 U times 1.660 539 040 times 10 to the negative 39 grams per atomic mass unit. Like that, we cancel out the atomic mass unit, and we get that the atomic mass, the mass of the atom of plutonium in grams would be 405.17 times 10 to the negative 24. Sorry, I just made a mistake here, and I just gave you the conversion. Wait, let me fix something here, because I was just giving the conversion. I just give you the wrong value. This is minus to the power of negative 24. I don't know. I got the 39. I don't know from where. So fix this. So this is to the power of negative 24, right? So we get 405.17 times 10 to the power of negative 24 grams. So this is the mass in grams of an atom of plutonium. Of the atom of plutonium. So now we know what is the mass in grams of one atom of plutonium, right? Now, if we divide the total mass of plutonium by the mass of one atom, we can calculate the total number of atoms of plutoniums that we have in these 4 kilograms. The total number we can calculate the total number of atoms of plutoniums where in those 4 kilograms of plutonium. So what we have to do now, we will divide this number, the 4 kilograms, by the mass in grams of only one atom. And that is going to give us then how many atoms of plutonium we have. So dividing, find the total number of atoms. We say 4.00 kilograms divided by 405.17 times 10 to the negative 24 grams. Of course, we have a problem here. We have 4.00 kilograms. We need to convert those kilograms into grams. So we know that 1 kilogram have 1,000 grams, or 10 to the third. So I can just, instead of putting kilograms, say times 10 to the third grams, because 4 kilograms would be 4,000 grams, right? So 4 times 10 to the third grams. And this is the grams per atom. So we simplify here the grams, and we're going to get that we have 9.872 times 10 to the 24 atoms of plutonium. So in these 4 kilograms, we have 9.872 times 10 to the 24 atoms of plutonium. Now, what was the original question? How many coulombs of positive charge? Well, I have how many protons per atom? I have 94 protons per atom. So if I want to find out the total number of protons, I will multiply the total number of atoms times the number of protons per atom, right? So to find the total number of protons, is equal to the total number of atoms times the number of protons per atom. So what is the total number of atoms? We found that value over here. 9.872 times 10 to the 24 atoms. Times how many protons per atom? 94 protons per atom. Like that, we can cancel out the atoms, and we can find that the total number of protons that we have is 928 times 10 to the 24 protons. So in 4 kilograms of plutonium, we have 9.872 times 10 to the 24 atoms of plutonium. And as each atom have 94 protons, we multiply this number times 94, 928 times 10 to the 24 protons. Now, if we multiply the total number of protons times the charge of one proton, we can calculate the net charge of protons, right? We can calculate how many coulombs, the number of coulombs of positive charges. So the number of coulombs, that is the original question here, of positive charges. And when they say positive charges, of course, they are talking about the protons, is equal to the number of protons times the charge of a proton. So the number of protons is 928 times 10 to the 24 protons times the charge of the proton is 1.60 times 10 to the times the charge of the proton is 1.60 times 10 to the negative 19 coulomb per proton. The protons cancel out, and we're going to get as result 1.48 times 10 to the 8 coulombs. 1.48 times 10 to the 8 coulombs. This is what we got in this case. 1.48 times 10 to the 8 coulombs. So how many coulombs of positive charges are there in 4 kilograms of plutonium if we know the atomic mass or the mass of the atom of plutonium and the number of protons in each atom? So we have 1.48 times 10 to the 8 coulombs. So what is the procedure behind this? First, you know the total mass of plutonium. You know the atomic mass of the atom of plutonium, and you know the number of protons per atom. So what do you need to do? You need to know how many atoms you have in those 4 kilograms of plutonium, right? So if I say, if I find the mass of one atom in grams, the issue is that they give me the mass of the atom, but they give me the mass of the atom in atomic mass units, in use, right? And I cannot divide 4 kilograms by a magnitude in atomic mass units because they are not, coherent units or similar units. So I have to convert first those 244 atomic mass units to grams. When I had the atomic mass units into grams, then divided the total mass by the mass of one atom in grams, I found the total number of atoms. When I multiply now the total number of atoms times the number of protons per atom, I get the total number of protons in that mass of plutonium, in the 4 kilograms. And now when I multiply the total number of protons times the mass of the proton, times the charge of the proton, now we can calculate the total positive charge that we have in the 4 kilograms of plutonium. So that is the procedure that we have to follow in a problem like this. So all these 3 problems are problems to try to relate, these ideas about, the electric charge, the mass of the particles, right? The charge of the particles,